All right, let's dive right in. Today we're talking about TCP versus UDP, the Internet's two messengers. These guys are like the invisible workhorses of the Internet, making all the decisions about how your data gets from, point A to point B.
So have you ever wondered about this? Why your bank transfer receipt shows up perfectly every single time, but then your video game stream stutters and lags? I mean, when you download a file, right, you expect it to be perfect. Every single byte has to be there. But if you're on a video call and it glitches for a split second, it's annoying for sure, but it's not the end of the world. So what gives? What's the difference?
Well, it's all about how the Internet decides to send that information, and that's where these two different personalities come into play. TCP and UDP. You can think of them as two totally different kinds of messengers. Each one gets hired for a very, very specific type of job. Okay, so first up, let's meet TCP. We're going to call this one the reliable professional. Seriously, this is the messenger you call when your package absolutely positively has to get there in one piece. No questions asked.
So, the official name is Transmission Control Protocol, and the key phrase you got to remember is connection-oriented. What does that mean? It means TCP doesn't just, toss your data out there and hope it lands somewhere. No way! It's super meticulous. It sets up this dedicated, formal connection between the sender and the receiver before even a single byte of your actual data goes anywhere.
And how does it do that? With this really cool process called the three-way handshake. It's like a formal introduction. First, your computer sends out a little SYN packet. That's basically it knocking on the door, saying, "Hello, are you there? Can we talk?" The server on the other end replies with a SYN ACK, which is like, "Yep, I'm here, I'm ready to go." Then your computer sends one final ACK packet back, just to confirm. Awesome, connection established. And only after all that back and forth does the real data start to flow.
And it's because of that handshake, that formal connection, that TCP can make all these incredible guarantees. We're talking error-free data transfer. It checks everything to make sure it's not corrupted. It guarantees ordered delivery, putting all the pieces back together in the right sequence. And get this, if a piece of the data, a packet, gets lost on the way, TCP notices it's missing and resends it. It even helps manage traffic on the Internet to avoid digital gridlock. I mean, it is so thorough.
So you can see why this level of reliability is absolutely crucial for certain things, right? Think about it. Loading a website, sending an email, downloading a big file, you just can't afford to have missing pieces. A web page with half its code missing would just be a broken mess. That's why TCP is the go-to. It makes sure everything arrives exactly as it was sent.
All right, now let's switch gears completely. On the total opposite end of the spectrum, we've got our second character, UDP, the speedy messenger. If TCP was that professional, reliable courier service, well, UDP is like the bike messenger just zipping through traffic. Their only goal? Get it there fast.
And its official name is User Datagram Protocol. The key word for UDP is connectionless. There's no three-way handshake here, no formal introduction. It just grabs the data, chops it up into these little packets called datagrams, and just sends them out. It's a total fire and forget kind of deal.
And this really sums up UDP's whole philosophy. I'll send it fast, but I can't promise it'll all get there, or in what order. It's all about one thing and one thing only: speed. It's not checking for errors, it's not worrying about the order of the packets, and if a packet vanishes into thin air, UDP has no idea. It just keeps firing off more data.
So you're probably thinking, why on earth would anyone ever use this? It sounds kind of terrible, right? Well, here's why. For anything that's happening in real time, speed is everything. It's way more important than perfect accuracy. Imagine you're in an online game or watching a live video stream. If the system stopped everything to wait for a lost piece of data, you'd get this huge jarring lag. The whole experience would be ruined. It's actually much better to just have a tiny momentary glitch and just keep the action moving.
Okay, so we've met the professional and we've met the speedster. Now let's do a proper head-to-head. Let's put them side by side and really see how they compare.
And this table just lays it all out nice and clean. You've got TCP, the professional, connection-oriented, super reliable, guarantees the order is right. But all that work, it makes it slower and adds a lot of extra data, what we call overhead. Then there's UDP, the messenger, connectionless, not so reliable, no promises about order, but because of that, it's blazing fast and has almost no overhead. They're polar opposites.
And really, this is the main thing you need to walk away with. It's the fundamental trade-off. When an application uses TCP, it's choosing reliability above all else. When it uses UDP, it's choosing pure speed.
And this chart really shows you why there's such a speed difference. It comes down to that overhead I mentioned. See, every single packet of data has a header on it. It's like the address label. UDP's header is tiny, just 8 bytes. But TCP's header, it's at least 20 bytes, sometimes even more. Why? Because it has to pack in all that extra information for sequencing and acknowledgements. It's simple, really. Less data to process means a much faster trip.
So after all that, which one's actually better? Well, that's kind of the wrong question to ask. It's not about better or worse. The real question is, which one is the right tool for the job? Let's bring it back to the real world. What uses what? Well, TCP is for all the stuff that needs to be perfect. Loading websites, sending your emails, downloading files. Your computer uses TCP for that. But UDP? That's for all the fast stuff. Live video streaming, online multiplayer games, internet phone calls like Zoom, even just looking up a website's address with DNS. All those things need to happen right now, so they use UDP.
And that really is the big takeaway here. The internet as we know it today just wouldn't work without both of them. They're not competing, they're working together. We absolutely need that meticulous professional TCP to make sure all our important data is accurate. And we just as badly need that speedy messenger UDP to make all of our real-time communication possible.
So here's a little challenge for you. The next time you're online, just think for a second. Are you browsing a website? Is a video loading? Are you in a game? Can you guess which messenger is at work? Are you counting on the careful, reliable professional, or are you banking on the lightning-fast messenger? Now you know the secret of how it all works under the hood. Thanks for tuning in.